I'll just start again. So last week we finished or went through a number of topics. We were starting to move a little bit now. We kicked off with variable scope. We saw that we had local variables and global variables, depending on where you declared your variable. Usually we try to keep our variables as local as possible, and variables can be kept local to a loop or local to inside braces, and that's called a block. And we also saw that there were certain conditions where you needed a variable to last outside of its block, so you needed to last longer. And in those cases, we declared variables at the top of our code, and we call those global variables. We also then moved on to use those variables in selection statements. So the selection statement was the if statement, and we saw we could test different conditions, and based on those conditions, we could then execute different lines of code. That took us on to events, and we looked at the mouse variables and system variables. By interrogating the system variables, we were able to execute code to do different things when we pressed the mouse button, for example. So we had examples with circles and squares being drawn in different colors when we click the left mouse button or the right mouse button. After that, we moved on to loops. So last Wednesday, thanks for everybody who stayed with us last Wednesday. We had quite a few technical problems, which we've been working through during the week. Hence, we're in a different room today, and hopefully things will work a bit better today. We've got all new hardware, so I'm hoping we have absolutely no downtime today. So it should move a bit smoother. So the loops that we covered, we looked at repetition. So loop is repeating code over and over again. And some of the questions that came up on the Slack channel over the weekend were related to loops. For example, if we have 1,000 lines of code, and each line of code is printing out a value out to the console window, isn't it more efficient that we would use a for loop rather than 1,000 lines of code? So this is something we'll be looking at throughout the course on all your modules, and that is the notion of which is more efficient. And for the moment, we want to be writing code that is efficient for us to write. And later we'll be looking for code that's efficient to run on a computer, because sometimes how you write the code can make it run more efficiently in the computer, taking up less memory and less resources and processing power. So when we started looking at repetition, the first example was a while statement, and we had a while loop. And what we learned by looking at the while loop was that we have an initial value that's set for a loop control variable. That variable is tested in a condition, and then every time we go around the loop, we must change the loop control variable. Changing it doesn't have to be just incremented; it can be changed by any value. But that allows the condition that's tested the next time around the loop to be changing. And if you don't update the loop control variable, you end up with something that we came across called infinite loops. To help us track down what's going on inside a loop, we also looked at the print and print line statements for outputting variable values to the console. And we also looked at the text statement for putting that same text out onto the display window with a nice font and size and color. So this took us into looking at the difference between static drawings, which we were doing up to last week, and now we've moved into animated drawings. And the key difference was that we use a setup and draw method inside processing. And by implementing the draw method, what we said was the setup routine is run once, but the draw method is run about 60 times a second unless you change it. And in some of the exercises, we looked at how to change them. So our labs, which we're a little bit nervous about because we're not sure, given the activity on the Slack channel, we're a little bit concerned that maybe people are not keeping up with the labs or not doing the labs. I can't stress how important it is at this stage. Unlike with Eamon, where you've got web, it's a 5-credit module, so it's going at a much slower pace. The 10-credit module requires twice the work. So if you haven't gotten started on the labs, really you need to get on it straight away, because you will find it too difficult to catch up if you leave it past this week. So this is the 3rd week. I would really encourage you all to get stuck into those labs this week. And for those of you that have been working your way through them, well done. The questions that have been coming, very good. Just a reminder, last week's labs, the key ones, they're the steps that you work through, and then they just follow on from the lecture, making you implement what we do in the lecture in code with slight changes. So there's not a huge difference there. But then there's the exercises which follow on from the steps, and they'll push you a little bit more. It's not exactly covered in the lecture. And then there's the challenges, which will usually have an element that you have not seen or heard of before, and you're encouraged to figure out how to do that or find out some new piece of code by looking up the reference to help you do that. So some of the things that you should have covered in the labs at this stage, we saw how to draw squares like a stairs going from top left to bottom right, spaced out to a specification. We also saw how to click to create target circles, and these target circles were not just circles, but they had many bands on them. We saw how we could modify some existing code to create that. And we looked at different ways of drawing a grid on screen, and we've had a few questions about those on the Slack channel, which we've been answering. And finally, the one that suggests that you know what you're doing at this stage is a chessboard. So you have to draw a chessboard which makes use of loops. And if you can draw the chessboard, there was one catchy bit in it, which was to use the Modulo Operator. And just if you don't know what I'm talking about, the Modulo Operator, we've been looking at arithmetic operators up to now. We saw addition, subtraction, division, and multiplication. The modulo operator is the percentage sign, and what it does is that if you divide a number by 2, it gives you the remainder. So that's a little tip for completing the chessboard. If you think of all the squares on a chessboard as being individually numbered, and you know whether to colour them in black or white based on using the modulo operator dividing by 2. So there's a little hint for those of you who haven't cracked it just yet. So on to today. Today we're going to be looking at methods in detail. Methods, another name for methods are functions. And I'm going to switch view here. We'll work our way through some slides, and we'll give you some questions then as well. Okay. Right, so our methods, let's get started. The term function is used in processing for calling line, fill, or any other function like setup, draw. These are all called functions, or that's how they're referred to in the processing documentation. But as we saw, we're learning processing, and the language that we're using in processing is Java. And Java calls functions methods. So today's class and the next class are titled methods. But when we talk about methods, we're really talking about functions or methods, effectively the same thing. The difference in the terminology comes from how programs were developed in the past. Functional programming languages used functions and procedures, and object-oriented languages, when they developed objects and classes, they tended to call the functions that they wrote inside a class as methods, and we'll be seeing that in the future. As this course is primarily about the Java language, we're going to be using the method vocabulary from now on. So method terminology, this is what we're going to be covering today, method terminology, and then using those methods to handle mouse events. So let's get started with method terminology. First thing is to recap on our methods in processing. First thing here is processing comes with several pre-written methods that we use. A method comprises a set of instructions that perform some task. For example, if you say rect, you know you're going to draw a rectangle or a square. Okay, you don't know how it does it. You pass in some values to help it do it, but it just draws a square, and you don't have to worry about how it implements it as long as you know how to call it. So we have a method call and a method implementation. When we invoke the method, it performs the task. Some methods that we've used so far: rect, ellipse, stroke, line, fill, etc. So some methods in processing. We have also written 2 methods to animate our drawings. So you might notice from last week we were using setup quite a bit, So when you were filling in your code inside setup, you were actually implementing or writing a method. The method was called setup. So it automatically is called once the program starts and shouldn't be called again. And it typically sets up your display window. So we had statements in there to set the screen size, change the background color usually. Another method that you've been implementing already is the draw method. And this is automatically called straight after the setup call, and it continually executes the code contained inside it. What we learned last week was it runs about 60 times a second. So we have some terminology now. We're going to look at setup in a bit more detail and identify the constituent parts in this method so that we can identify how to write other methods ourselves this week. So the different parts, we have a method signature and a method body. So the signature is the header and the method body is the bit in the curly braces. We had a name for what was inside curly braces last week when we looked at these, and I might ask if you would reply in the programming channel in Slack right now if you can remember what we call code inside curly braces from last week. A block, yeah, cool. We had another name on it as well. So quite a few answers there. We have blocks and body, which is they're correct. Another term though that is used is a compound statement. So you might make a note of that, compound statement. When you put multiple statements together and wrap them in curly braces, this is referred to as a compound statement, and that will come back. We'll be seeing that again. Okay, so back to this, our method terminology. So we have signature, and we also have, there's our signature, and it's this part. And we also have the method body, which is what's inside the curly brackets, otherwise known as a compound statement. Okay, so void setup. The void word is called the return type. Then we have the name of the method, and then we have a parameter list. And you've been using these, but now we're looking at what are these different parts called. Okay, so we have a return type, a method name, and a parameter list. So let's look at the return type and maybe dig in a little bit deeper to see what's involved in return types. So methods can return information. If they don't return information, we use the void keyword. So void means nothing is returned from the method. So it has, when you call the method, it does something, but it doesn't give you back any answer. Void is the return type and must be included in the method signature if your method returns no information. Okay, so that's why we come across this void. When a data type appears before the method name, this means that something is returned from the method. So the method has to do a job, but then it has to give back an answer. Okay, a return type, a return value. Within the body of the method, you use the return statement to send that value back out. So when we go implement our code, we'll find a return statement for any method that we're writing which doesn't have a return type of void. So what are the other return types? We'll look at those in just a second. Here's an example of a method called times2. So this is the name of the method, and it returns an integer. So it's going to return a whole number. So we have to work out what that value is inside of the method. The red int in the function declaration specifies the data type as being int, and you've also come across other data types. So what I'd like to ask you to do is in Slack, can you write out all the data types you can remember from the first 2 weeks, please? If you do that now. Okay, that's great. So we have float, string float, int, double, boolean, strings. Yeah, char. Looks like you've got them all. Okay, that's great. Well done, everyone. So what we're saying is when you write a method, it can return a data type. The data type are all the ones you've listed, but we also have void, and void means it doesn't return any value. So if we look on screen, we can see that the draw method that we've been using up to now, it actually is implemented as a return type of void, which means draw doesn't return any value. But inside of draw, we can call times2. It will call a method times2, and we're passing in a value. It takes that number and multiplies it by 2. And the important bit here is that it returns the number. So there's a return statement inside of the method which gives back the value. Okay, so these are all the ones that you should have gotten: boolean, byte, char, int, float, string, double, and most of you got quite a few of those, so well done, everyone. Now you can only have one return type per method, and that's because you're specifying a data type. You don't specify multiple data types before the method name, so therefore there's only one type per method. Let's move on now and look at method names, and if we look at the rules to the method names that you can use. So method names methods are functions. You're doing something, so we use verbs, which are action words, to describe what the method does. For example, calculate tax might be a method, print results a method, and I'll ask you to, in Slack, if you can come up with a method to do something, anything at all. And we'll examine your answers and see. Okay, so some examples we have here. Wages. Wages, is wages an action verb? Don't think so. So maybe it's calculate wages. Okay, and if it was calculate wages, you'd have calculate with a small c and wages with a capital W. Just to remind you, we've come across camel case already. We said we have multiple words in our variable declarations. We would use camel case where we start off with a lowercase and then every subsequent word is capitalized. So Dennis, you might just update that for us in Slack, calculate wages, the way you would actually write it in code. Get date, that's fine. Measure weight, fine. Time lapsed, fine. Void drink. Again, drink is a noun, can be a verb, so maybe you might expand that. Yes, you're saying drink returns no value with void in front of it. Get total, increase size, yeah, as in drinking, yeah. So maybe get drink. Get and set are two words that we put in front of a lot of other words to generate what are called getters and setters, which are methods that we'll be seeing in the coming weeks. Okay, thanks for that. Thanks for your input. Method names, again, should use verbs and be mixed case with the first letter lowercase and the first letter of each internal word capitalized, and we refer to that as camel case. Okay, so again, we're looking at method terminology, and the next part of the method is the parameter list. And we've used parameters, passing values into methods already. So the parameter list is what comes after the parameter name inside parentheses. So methods take in data via the parameters. Methods do not have to pass parameters. For example, setup has no parameters at all. Here's examples of other methods with no parameters. So we've already seen no stroke. So again, it's just no stroke and then parentheses with nothing inside. Methods do not have to pass parameters, and the methods above, no cursor, setup, no stroke, these have no parameters. So they don't take in any additional information, they just have a job to do, but you can't pass any information into them. Now, when we want to pass some information into the method in order to maybe for use inside the method to work out some values possibly, then we have to pass in parameters. So here we have an example with void stroke weight, float weight, and void size int width, comma int height. You can see why the writing is there in a second. When we import our slides into Adobe Connect, sometimes the Adobe Connect has to convert them, and it puts things off a little bit. So that's what's happened with this slide, hence my scribbling on top. So the float in stroke weight, float is a type. Okay, so this is the type here, and the name of that parameter is weight. Okay, so what we're saying is a parameter is like a variable declaration. It has a type and it also has a name. Okay, so the type can be any data type, including void, and name is the name of that value. Okay, if a method needs additional information to execute, we provide a parameter so that the information can be passed into it. The first method, stroke weight, has one parameter, and the second method, size, has two parameters. Okay, so I've got some questions for you. Let's move to some polls. Yeah. Okay, so we're going to implement some polls for you. Let's try this out. And we'll open the first one. So based on the content that we've just worked our way through, got some questions just to make sure you're still awake. So processing prefers which terminology? Procedure, function, or method? Okay, let's broadcast the results to you. So we had 2 people think it's procedure. We have 11 people suggesting function and 7 with method. Okay, so let's go through those. Procedure is incorrect. Procedure was favored with programming language called Pascal. Function is our most popular answer, and yes, processing prefers the function vocabulary or nomenclature. It's the word that it prefers to use. However, we're using Java inside of processing, and that's why we're going to be talking about methods instead. But the question was, which one did processing prefer? The correct answer here is function. Okay. Let's try another one. So this one is, Java prefers which terminology? Okay. I'm just waiting on one more. Okay, all in. Let's broadcast the results here. So we have 2 people who've selected function, and 17 of you have said method. Okay, so 90% of the class saying method. Yes, Java prefers to use methods, processing prefers to use function. Okay, so the answer here is method. Okay. Let's get you some more. Let's open this one. How many times a second is setup called? Some of you are answering in the Slack channel. If you wouldn't mind moving over to, we're running a poll on Adobe Connect, and you can take part in the poll. And we're waiting on 2 more. Okay, let's take a look. So how many times a second is setup called? So we've quite a few different answers here. How many times a second is setup called? Well, it's not 60, it's not 10, and it's not 2. And let's talk about 0 and 1. Setup is called at the start of your program. Okay, it's an initialization, and it's called once, but it isn't called every second. So I think it's probably a badly phrased question, but 0 would be the most correct answer there. And I understand some of you, if you've selected 1, which was my intention with the question, which was it's called once, but not once a second. So strictly speaking, 0 is the correct answer here. Okay. Okay, let's get you another one. So in order to process mouse events, actually we'll leave that one just for now because we haven't covered that yet. Okay, let's see. Okay, so what we're going to do now is we're going to take a look at some of the programs that we wrote last week, and we're going to see how we can bring those over and handle them using mouse events. So we'll take a break in a few minutes once we get past this section. So let's continue. So using methods to handle mouse events. So if you think about a mouse, you can click it, which we've already seen, Pressing is slightly different. So clicking is you press down and you release, whereas pressing is you've pressed down the button, but you haven't released it yet. So we then have released. So this is, you've already pressed the button, and when you release it, that causes another event. So you could implement mouse clicked by breaking it into two separate steps, the pressing and the releasing. We can also move a mouse, so we can get information back as to whether the mouse has been moved or not. That can raise an event. And we can also drag a mouse. And the difference between moving a mouse and dragging a mouse is that when we move a mouse, we don't have any button pressed, and when we're dragging the mouse, there is a button pressed. Okay, so that's the two key differences. Mouse and keyboard events only work when a program has a draw method in it. Now, you don't have to have anything in the draw method, but if you don't have a draw method, you end up with a static drawing, which we saw in the first week. And then last week, we saw how we could have what are called animated drawings by including the draw method. So it's quite important that you make a note of this. Without draw, the code is only run once and then stops listening for events. If we want to handle events, then we have to include the draw method. Okay, so let's take a look at this example. We have setup, and it's got some code in here. Size, background, text align, text size, fill, and then we use the text statement to output the message in the middle of the window. The mouse has done nothing. So this is a static program. Okay. By including the draw method, it means that now we can start handling events. And I've just given away the answer. Why did we include the draw method, particularly as it's empty? Can you answer that, please, in Slack? Okay, good. You all seem to be on the ball. If we don't have the draw method, then we can't handle events. So even though there's nothing in it, we still need to include it so that other events or other methods can be handled. Okay, so draw is required because mouse events only work when a program has it. So now let's take a look at some of the events that we highlighted a moment ago, how they might be implemented in code. So the first one is mouse moved. So what we want to do is we want to know when the mouse has moved. We want to do something when the mouse has been moved. And what we're doing here is we're changing the background to this, I think it's a pinky color. And the message inside it is text was moved. Okay. The width divided by 2 and the height divided by 2, that's saying where to position the text, as we saw last week. Okay, here's another example, the mouse dragged. So mouse dragged is handled the same way, just choosing a different color. And this is possible because we included this draw right here. If we didn't include the draw, then we wouldn't be able to write the mouse dragged method. By including the draw, we can write it and it will be handled and it will run at the appropriate time whenever we drag the mouse. Here's another example. A question from Patrick. Okay, Patrick. We'll pause for you. Yeah, if you write your question in Slack, why do we need to put in the mouse move method? Mouse move method. Because what we're learning about is we want to be able to handle different events when they happen. And what we're showing you at the moment is we give you a table with a whole load of events. I'll just skip back to those. Let's just skip back here. So if we take a look at this column here, Okay, these are all methods that can be handled. You don't have to handle them. We're just showing you here's how we can handle events. Okay, we're setting up an event handler by calling the draw method, and then these are all the different things that we could handle. Okay, thanks for that. Let me just skip on. Here's another example, mouse released. Exactly the same. Mouse pressed, then we can get into a bit more detail. So last week we saw some code to check if a particular button was pressed, and if it was, then we clear the screen. So here we're seeing mouse pressed. We can do the same thing. If you know that the mouse has been pressed, a mouse button that's been pressed, the next thing to do is to check, well, which button was pressed. And last week we saw the if statement for selection. So we can use that inside an event handler to figure out which button was pressed. So what we're going to do is go through the programs we did last week, look at how they were implemented using variables. And today we're going to look at how we rewrite those using event handlers or methods. Okay, so I'm going to take a break after these, and I'll handle any questions that are coming up on the Slack channel. But I'll go through the examples first. So here's one of the programs from last week. This is example 2.5. If the mouse is pressed, draw a grey square, otherwise draw a grey circle. That's what you implemented last week. And this is the code you used to do it. And the key part of the code was this if statement, which checked if mouse is pressed by looking at the system variable, mouse pressed, then call the rect function, otherwise call the ellipse function. Okay, but if we implement that a different way using mouse methods, first of all, we'll have to include the draw method to be able to handle events, and then mouse pressed can be handled and mouse released can be handled. So if we compare side by side your code from last week with code from this week, and we'll break it down what happens and what moves where. So the first thing is, in order to handle events, you have to have a draw method, and then this enables you to have the event methods for the mouse, in this case mouse pressed and mouse released. If we look at our setup, the size still stays the same. In the draw method last week, we had a background, a stroke and a fill, and now we're moving that into the setup routine because it doesn't have to be implemented every time. This information only needs to be done once, so it's more efficient. Okay. But the key part of the code then was we had to draw a rectangle, and we only draw the rectangle when the mouse is pressed. So hence we can move that rectangle statement, instead of having an if statement, we're just putting it into the event handler. Otherwise, we draw an ellipse, drawing a circle. And we can see two calls here. One is in the mouse released, this one here, and the other one is in the setup. Okay, so the circle is drawn straight away, and then as you release the mouse, it'll be drawn again after pressing on it to create a rectangle. Here's another example. We had a program where if the mouse is pressed, set the fill to white, otherwise set the fill to black. This is the code you wrote last week. Again, the key part of it was the if statement. And if we implemented the same code this week using the draw method and then our mouse events methods as well. So again, it's probably easier to look at it in this view. So what we've done is we've taken our setup and draw from last week, and we've moved the code around so that we're putting our code inside event handlers or methods, and that simplifies the code. We don't have any if statement here. So if we take a look, the draw function enables the events to be raised. Then we have mouse pressed and mouse released. The setup is the same, but we move the background into the setup function from last week. The fill can be handled when you press down the mouse button. You know you want to change the fill to white, and if it's not white, then it's going to be black. So we handle that in the release when you release the button. Otherwise, at 60 times a second, the draw function is being called. And what it's doing is it's constantly drawing the rectangle. So in between each of those 60 redraws per second, what's happening is if you press down on the mouse, it's changing the fill, but the split second that you release the mouse button, it changes the fill back again. Okay. Okay. So another example that we had last week, this actually was quite complicated to describe, but really simple to implement. We had, if you press the left button, you want a black square. If you press the right button, you wanted a white square. And if no button is pressed, then we have a grey square. So again, the code last week was a complicated nested if statement. This section here. And what we want to do is to take that code and include it in an event handler to maybe simplify what we do. So again, we're going to need a draw to do the drawing. It's going to draw the rectangle. But in between the draws, we might press the mouse button down. And if we do, we're going to have to release it. And what you see is the if statement just checks, well, which button was pressed. If it's the left one, change it to a black fill. If it's the right one, change it to a white fill. Otherwise, you've got a grey fill in here. So let's compare the before and after. On the left, we have the program you wrote last week. And on the right, we have the program we're writing this week, which includes a call to the draw method to draw the rectangle. It does the actual drawing. And as we just stepped through it, the big if statement that you had from last week, it's just checking inside the code this week, is the mouse button left or is it right? And then set the fill accordingly. Otherwise, when the mouse button is released, we have a grey fill. And once again, just highlighting that the draw method is what's actually doing the drawing. Last one is 2.8. This was the drawing the circles, and when you press the mouse button, what it did was it cleared the screen so you could start drawing the circles again. So what we learned previously was that if you call the background function with 0, that's going to create a black background, and that's the same as clearing the screen. So in last week's code, we handled if the mouse pressed system variable is true, then the background is changed to black. And by putting that in the draw method last week, this was run 60 times a second, and then we could draw our ellipse after that. Let's see how that pans out in our new setup using mouse methods. So again, in order to handle the mouse events, the mouse methods, we're going to have to call the draw method in our code. And mouse pressed, then every time you press the button, that's all that needs to happen. We call the background function. Okay, so that simplifies the code. And it allows us to handle events rather than including these system variables inside the draw method. Yeah, one more example. This is the 2.5 we've already covered. What we're doing here is just looking at an alternative way of doing it using mouse moved and mouse clicked instead. Okay, so I think that's enough for the moment. It's 17 minutes past 1. I have another set of content that we need to go through where we'll start writing our own methods. But I think it's a good time to take a break. If you want to get a cup of tea, I'm going to take a 10-minute break, and we'll set that up for you now. And in between, when you're having your getting your tea ready, if there's any questions that you want to ask, you can do that in the Slack channel, and I'll try and respond to those during the break. Okay, so let me just set up a timer here for 10 minutes. It's good. And let's show you guys. Stop, start. Okay, thank you. Okay. Okay, we're just getting coming back from our break. Some great questions there during the break, which we might share with the rest of you, just to go over some of those. Or actually, be no harm for you just to take a look at the questions on the Slack channel and my responses just while I'm switching to the next set of slides. Okay. Okay. So 1:30, we'll make our way through the next piece of content. Okay, so we've been learning about methods and the terminology that's used with them. We saw they had a return type, they had a method name, and then inside parentheses, any parameters that you want to pass into the method. We also saw that you could return a value from a method. So let's just go over some of that again before we move it on. And what we're going to be doing is writing our own methods before the end of today's talk. So the terminology is the return type, method names, and a parameter list. You might recall we have a set of instructions that perform a task. That's what a method does. We invoke the method, it performs the task, and some methods that we've used to date were rect, mouse pressed, setup, draw, and so on. Here's an example of a method called setup, which returns no value. It has method signature is the header or the top. That term header is used in other languages. And then the method body is the bit that actually implements what gets done when you call the setup. So it's a compound statement, which is a number of statements inside curly braces. We have the signature is a return type, the method name, and the parameter list. And what we also learned was that return types, let me just change this, methods can return information. If they don't return information, we have to put the void keyword in front of the name. And if they do return information, then we use a data type, and that can be any one of the data types that you listed earlier. We can only have one return type per method though. And if we are returning a value, then it means inside the implementation, inside the curly braces, there's going to be a return statement, and that is going to return some value. Okay. Oh yeah. Drawing on. Okay. We also, if we look at it in a bit more detail, hopefully this diagram will help. Here we looked at the ×2 method. We said it returns an integer, and here we can see how that gets returned right here. Some trouble. Let me select that. Okay, back in business. So the return statement here, we've called ×2 and a number has been passed in. So let's say the number is the number 4. We pass 4 into this by setting, well actually we have an example which is 30. So let's use the example that we've got. So 30 comes into the ×2 method. And what we do is we have an assignment statement which says number is assigned a value 30 × 2. So number becomes 60. So now we have number is 60. And we're saying this new keyword return, we're saying return 60. What that actually does is it sends the 60 back out of the function, which I've indicated with this arrow, and ×2 then of 30 evaluates to 60. And then that 60 is placed in the result using this assignment statement. Result equals ×2 brackets value, where value is 30. So what we end up with is 60 comes into the result variable, and then we can print line the 60 to send that 60 out to the console. So that's actually what's happening when we pass variables and numbers around inside and outside of methods using the return statement. That's actually what goes on. We also saw that method names should be verbs and use mixed case. Methods take in data via their parameters. So they do not have to pass parameters. These methods don't need any additional information to do their tasks. These ones here. Okay, so they have no parameters. And if we look on the right hand side, I'm going to take a look at ones that do actually take in information. Provide a parameter list so that the information can be passed into the method to make it or help it do its job. And a method can have any number of parameters. So we saw this first one, stroke weight, has 1, and the second one here has 2. Okay, so what we're going to do now is we're going to look at writing our own methods. And just before we do, I'm just going to ask you a couple of polls. So we'll switch to the poll. Let's bring this up. Okay, and you should see a poll on screen. I'd ask you to fill in the or select the correct answer. So in order to process mouse events, you first need setup, draw, mouse press, mouse release, mouse move, or no vote. So think about it. We want to handle mouse events. What do we have to have? Okay, so answers are in. Somebody changed at the last minute. Okay, so here's the answer. So yes, we call setup, and we have a habit of calling setup at the start of every program that we've been writing. But look at what the question is asking you. It says, in order to process mouse events, you first need what? And what you first need is a draw. Okay, so draw is the answer I was looking for there. Well done if you got that correct. Okay, let's get you another one. Okay, so how many times a second is draw called? Follow on from a question we had earlier. Earlier we were asking about setup, now we're asking about draw. Okay. Let's put the results out. So we have 2 people who've said 0, and 90% of you have said 60, and 60 is the correct answer. So by default, draw runs 60 times a second, and that's what we saw in last week's labs. So if you've missed that, you might want to take a look back on last week's labs. Okay, thank you. Let's hide that one. And one more here. Let's take a look at this one. You might, again, this is a different type of question. There are multiple correct answers. Can you select all the ones that you think are right? Identify the correct parts of a method signature. Okay, so we're nearly getting there. A couple of more seconds and then we'll go through it. Okay, things seem to have settled down, so let's broadcast the results. So most of you got the first two. So the method signature, another word we used today, was header. It's the bit that comes at the top, and the body comes after the signature, so the body is in the curly braces. So what we're talking about in the method signature is everything that came at the top. And what we saw today was that it had a return type. So if you got return type, you're correct. It also had a method name, which was fine. Variable assignments, not part of the signature. We said that the parameter declarations were types of variable assignments, but really the answer here is the parameter declarations. It could be 0 or more. So if you have parameters, you'll have parameter declarations, which will appear like variable assignments, but 0 or more is the correct answer there. Method body is not part of the signature, that comes after. And the compound statement, that's how you implement the method body. So a couple of incorrect answers, but the two main ones were right, the return type and the method name. You can see with multiple choice and multi-select questions, we can get really tricky, and even though you would think they would be easy to answer, we can make them quite tricky. So you need to know your stuff there when you're put on the spot. Okay, but well done for your answers. Okay, so let's close that and we'll move on. Okay. Okay, so we're going to be looking at now writing our own methods. We're writing our own methods. The methods some of them will have no parameters, some will have parameters, and we'll also write one that returns data. So we have 3 example types to look at. So let's go through those. So writing methods with no parameters. For example, draw a red square at a certain XY coordinate. So let's take a look at that. So we're not going to specify the XY coordinate. It's going to draw the square at an XY coordinate. We're not sending in any information. It's just going to draw a specific red square. Okay. So let's take a look. We have a setup. We have a draw, and the draw is calling the draw red square is going to call our draw red square method, and this is what we're writing today. So we're looking at how do you actually create your own methods. So we're coming up with a new name in the same way we used to come up with variable names. We're now coming up with method names that we come up with ourselves. So this one is called draw red square. It doesn't return any value, so it's void. It just does a job, and it doesn't take in any parameters in this example. So all it does is it executes the code, change the fill to red, and then draw a rectangle somewhere. Okay, so not a particularly useful method, but it gets us started in how to write our own methods. Okay, so let's take a look. So that's the call. Let's take a look at one with parameters. So this time we're going to do something similar. I'm just going to make it slightly more complicated. We're going to update the code so that you can pass in the length of the square into the method draw red square. So we're passing in a parameter, and the parameter is the length on one side of the square. So again, we have a setup and we have a draw, and this time we implement the draw red square. It returns no value again, so it's still got a void as the return type. The name of the method is draw red square, but what's different this time is the int length. Okay, so it's taking in a parameter. And in order to call draw red square, we now have to put a number, an integer, and that can be a hard-coded value, or it can be a variable declaration, a variable that we've already declared that gets passed into draw red square. So the 60 gets passed in to the length parameter inside of draw red square, and then any time that we refer to length inside of draw red square in this example, what we're actually doing is we're saying replace that parameter with 60. So this is the code that gets executed. Let's make it a bit more complicated again. So we've passed in the length, but now we also want to pass in the location. So we can pass in an x coordinate and a y coordinate into the method draw red square. So again, we have a setup, we have a draw method, and the draw method is going to call draw red square. This time though, it's got 3 parameters going into the draw red square method. And again, the values that are passed in then are just used inside the code. So let's take a look at that. Here's the call. It passes 60, 70 and 40 into the length, x coordinate and y coordinate, like so. So then those values are used inside the method. So if we have length is 60, so that's going to be 60 as before. The x coordinate receives 70. So anywhere where we have x coordinate, that gets replaced effectively with 70. And the y coordinate is 40, so that gets replaced like so. Okay, so writing methods with parameters. So now update the code so that you can call the draw red square multiple times. Okay, so let's have a look again. So we have our draw red square method that we just wrote. No changes here. And this is where the change is. So we had the draw red square call, but what we're introducing now is we want to call it multiple times to draw multiple squares. So what we've got is a for statement that we covered last week. Our for statement here says I is initialized to 1. It goes around and implements what's in the curly braces. So it's going to call draw red square, passing in a value of I equals 1. So first time in, we have 25 by I multiplied by 25, so that makes that 25. And again, I is 1 times 20, so this one's going to be 20. When it executes that code, it comes back up around the loop and it tests this condition. Is I less than 7? And if the answer is no, it's going to go back down again. So it's going to call draw red square again. So it's going to call it with I being incremented to 2. So what we get the next time is 2 times 25, which is 50, and 2 times 20, which is 40. Back around the loop, fails the condition. Sorry, I is less than 7, so it meets the condition. And I is incremented, so it becomes 3. So then we have 75 and 60. And it keeps going around, drawing the squares, and you remember that this is the x and this is the y. So it's changing the position that it's drawing the square at. So this is why methods are useful. We can parameterize them and then use loops for repetition to write very efficient code to do complicated things, particularly with graphics. Okay. So when draw red square is called, again, the values are passed into the parameters and then they're acted on inside of the method. Okay, so we've had a method with no parameters, we've had a method with parameters, and now we're going to look at a method that returns a value. And to do this, we're going to look at times 2. So take in a number, multiply it by 2, and return the answer. Okay, so the answer then can be printed to the console. Okay, so the important thing is anytime you have a method that returns a value, you have to have a return type that's not void. So in this case, it's int. And in order to return the value, you have to use the return statement. And you must return the type that's expected. So we've already stepped through this earlier in class. we have times 2, which takes in a value. That value is multiplied by 2, and then we have a return statement to send the value back out. Okay, and we're going to store that in this case, result equals times 2 the value. So times 2 the value is times 2 with the value 30 coming in. So we're calling this. We calculate that value is now 60, and then we're going to return 60 as the return value of the method called times 2. So what happens is this equates back to 60. The 60 gets stored in result, and then the result is printed out to the console. Okay. So that's our questions for today. I'm going to ask you 1 or 2 questions, and then I'll take a look at the channel. So what I'd like you to do is I'm going to write the question in Slack, and I'd like you to respond to it, please. Okay, so the first one is, can you write a method called draw circle anywhere? Okay, so if you reply to the thread, write a method to draw a circle anywhere. And sorry, I'll make that a bit simpler because that's a bit long. Write a method header to draw a circle anywhere. And if you could just reply to that, please. Okay, good stuff. So the important thing here is we're drawing it anywhere. We know it's drawing a circle, but it's not returning a value. So Niall, you need to change your void. There you go, you fixed it. Good man. Change the int to the void and it's sorted. Okay, so those responses are good. Let's modify it now to take in the radius of the circle. So modify to take in the radius. Oh, put that in the wrong place. Good, so you're taking in inside the brackets you have Eddie, you'll need to fix that. So the parameters have a data type followed by the parameter name. Okay, so it has to have a data type followed by the parameter name. So we're not calling the method, we're looking for the header of implementing the method. Okay, that's good. And some of you have used int and more of you have used float, and that's fine. So you can see that we use different types. That's great. Let's give you one more. This time we're going to write a method to return a value. And what I want you to do is to write the method called find largest. And it returns the largest number. Again, we don't have to worry about how to implement it. What we're focusing on is how would the method header be written, or the method specification be. in order to return the largest. Okay. Again, because I didn't specify, you could have returned any data type. Some of you have returned int, some of you have returned double, float, but void, Mike, sorry, you'd have to return some data type. So find largest, what we're asking you to do is to change it so that it returns some value, which can then be stored in a variable. Okay, good man. Okay, folks. So that's your questions, or that's the content I want to get through for today. We're almost finished. Thank you very much. I think we're on time still. Yeah, with a break. Happy days. So the recording will be available afterwards. Again, we have Adobe Connect recordings, and shortly after, where possible, we put up the YouTube ones, which are accessible from the tutor's website. I hope you found it okay today. It is getting harder and we are moving a bit faster, and it is really, really important if you are having any trouble to let us know so we can help you. I think this week should be a busy week in the labs, the allocated times. I would encourage you to take advantage of them if you're having any trouble. But most importantly, get through the labs. Do these steps. Take a look at the exercises. You should be able to do the exercises. The challenges you might not get the answer to, but if you can get even some of the way there, that would be really, really good. Okay, so thanks very much. Okay, and stay in touch, stay online. We're here to help. Okay, thanks.